All right, so in this video, we're going to be talking about how to use scatterplots in reports. So, first one says, consider the following graph. Who are the subjects in the study? What are the variables of interest? And thoroughly describe the information illustrated by the graph, choosing at least 2 data points to help with your explanation. So, we've got 3 things that they want us to find. They want us to find who are the subjects of the study, what are the variables of interest, and then thoroughly describe the information illustrated by the graph. So the very first thing is subjects. So if I'm looking at this graph, I can see that I'm talking about 2007 tax tables for single filers, and it's comparing the amount of tax owed compared to their taxable income, right, in thousands of dollars. So for the subjects, it's just going to be single tax filers in 2007. For the variable of interest, I'm just going to put VOI. Variable of interest, we're comparing each person's taxable income right here. We're comparing that to the amount of tax owed, okay? So we've got each person's taxable income and amount of tax owed. And then the last thing they want us to do is just talk about describing the information illustrated by the graph, choosing at least 2 data points to help with your explanation. So if I'm looking at this graph, I notice that a single person making $10,000 in taxable income, so if I draw a line right here at $10,000, they're going to be paying about $1,000 in taxes. So, here, let me clean this up a little bit. So we got a data point right there. Meanwhile, someone who pays or makes $50,000 in taxable income will be spending about $9,000 in taxes. So I'm going to write that right here. So a single person with $10,000 in income pays about $1,000 in taxes, while a person with $50,000 in income pays about $9,000 in taxes. Number 2 says, describe the information illustrated in this graph, then compare and contrast this display with the graph in question 1. So if I'm looking at this graph, first off, the first thing I notice is that this original graph in number 1, is going up. It has a positive trend in taxes paid. Meanwhile, the second one is talking about the head of household, $50,000 taxable income before child deductions. And I notice that this one is going downwards. And so it's going to have a negative trend. So I'm going to talk about, first thing I want to say a head of household filer. We're just going to talk about the title. So a head of household filer with $50,000 of taxable income and no children pays almost $8,000 in taxes. And you can see, if you look at this, we've got someone who is making $50,000 with no children. So I'm marking it right here. The number of children is 0. They spend almost $8,000 in taxes. Meanwhile, if you look at someone who has 4 children, they're spending about $5,000 in taxes. So I'm going to write about that. So I'm going to say, if he or she has 4 children, they pay about $5,000 in taxes. Now, if we're trying to compare it to the first graph, we've already talked about that. We know that this graph in question 1 is a positive trend, is going upward. The more money you make, the more taxes you pay. This one, the more children you have, the less taxes you pay. So I'm going to say first graph is increasing. While the second graph is decreasing. And now part 3 is a reflection. It says, use the previous graphs to complete the following sentences. Now, a person with higher taxable income pays higher taxes. This is what we saw in the first graph. So higher your income, the higher the taxes. Now, a person with lower taxable income pays lower taxes. Now, this is an example of a positive association, right? Positive. And I'm going to put in parentheses graph number 1. Okay? So if I go back for a second, again, if you see this, it's going upwards as we move down the graph. As we go to the right, this graph, these dots go in an upward trend. So this is what's called a positive association. Now, a person with fewer children pays higher taxes. And a person with more children pays lower taxes. So this is an example of a negative association. And in parentheses, I'm going to put graph number 2. Okay? So again, the more children you have, the less you pay in taxes. Okay? Now, number 4 says, in actuality, head of household filers with $50,000 in taxable income and the same number of children could pay different amounts of income tax, as shown by the graph on the right. These differences result from tax credits and expenses such as childcare that can reduce the amount of tax owed. Compare and contrast this new graph with the original on the left. So we've got the original graph from question number 2, and then we've got this new graph right here, and so it's got a lot more dots on it, and they just want us to compare and contrast both of these. So the first thing I notice, the original graph is a negative trend, and then the second graph is also a negative trend. So I'm going to write that. I'm going to say both graphs have a negative association. Something else I noticed is that with the new graph, more data that's more spread out. So we've got more dots, so that means more data, and these are kind of more spread out than the original. These are more in a line with each other. These are kind of going up and down. They're a little bit more spread out. So I'm going to say second graph has more data, and is more spread out. And then the other thing we said was first graph is more linear. Question 5 says, now consider the following graph. What info is displayed, and compare and contrast this graph with the others you have analyzed. So the first thing we got to figure out, what is it showing? Well, if we look, it says that it is showing the fuel efficiency for passenger cars, and it's comparing the miles per gallon to the miles per hour. So I'm going to say this shows the optimal gas mileage for cars. And now, I also noticed that as you go up in speed, the graph starts to go up for miles per gallon. It starts to increase. So the faster you're going, the better gas mileage you get. But that kind of stops after a while. It looks like it starts to decrease again around 45 to 50 miles an hour. Around right here is where it peaks, and then it starts to go back down again. So if you're going 65 miles an hour, you're not going to be getting as good of gas mileage as you would if you were going 45. So I'm going to say the optimal MPG peaks at certain speed. And you can see if you're going any slower or faster than that optimal speed, you're going to be getting less gas mileage. So here is our optimal speed right about here. And then any slower than that, you're going to be doing less MPG. Any faster, you're going to be doing less MPG. So I'm going to say any slower or faster will decrease your MPG. And then, as you can see, it's definitely not linear. These dots do not follow a straight line. So they go up and then down, so they're curving, right? So we're going to say non-linear. And it changes from a positive to negative association. And now number 6 says a survey of students asked, how many siblings live in your house with you? And how many pets does your family have? The results are displayed below. Comment on the graph, comparing and contrasting it with the previous graphs. So as you can see, we've got two different variables here. We've got a variable showing the number of siblings compared to the number of pets. And you can see that these don't even line up at all. So they're all scattered all about randomly. As compared to something like the gas mileage, this really isn't linear, but they do follow a certain pattern. Same with the household income compared to the number of children. These are a negative trend all the way down. So we can say that it shows no pattern at all. Okay. And more specifically, we're going to say that the number of siblings and number of pets have no correlation. Now, number 7 says, when analyzing a display of bivariate statistics, bivariate meaning two variables, you need to consider the following. There are 3 things that you need to look at. You need to look at form, you need to look at direction, and you need to look at relative strength. So form, ask yourself, does the graph exhibit a linear or nonlinear pattern? So linear or nonlinear pattern. Direction, does the graph exhibit a positive relationship, a negative relationship, or neither? And then relative strength, are the data points tightly clustered along the line or a curve, which means they are strongly associated, or are they more scattered? Are they weakly associated? So you're going to say, anytime you look at a graph, you need to be able to tell me, is it linear, is it nonlinear, is it positive, negative, or neither? And is it a strong association or a weak association? So using these guidelines, analyze the following graphical displays. So we've got a graph showing the husband's and wife's age, comparing each other's ages. And then we've got another graph showing men's division 2008 Louisiana Trails Marathon. We're comparing the age of the runner to the average miles per hour. So if I'm looking at this first one, husband's and wives' ages, I notice that for the form, is it going to be linear or nonlinear? Well, these seem to be following a line here, right? So I'm going to say that it is fairly linear. Direction, is it positive, negative, or neither? So it looks like it's going up as the graph moves on. So I'm going to say that it is a positive association. And then what about strength? How closely compact are these dots? Are they scattered all over the place, or are they following kind of a straight line together? And it looks like these are following a fairly close together, right? As the husband's age moves up, the wife's age moves up with it. So this is a fairly strong correlation. And now for the men's division 2008 Louisiana Trails Marathon. First thing we've got to ask, form. Is it linear or nonlinear? These aren't as linear as this one, but you can still see they're following a line somewhat, right? As the person's age goes up, their average miles per hour go down. So I'm going to say that this one is somewhat linear. Okay, direction. Is it a positive trend, negative trend, or neither? So like we said, as their age goes up, their average miles per hour go down. So you see this negative trend in the graph. So this one is going to be negative. And then strength, how strong is this association? Is it really compact where all the dots are following in a straight line one after another, or are they more scattered out? So in this one, it looks like they're more scattered out, right? As the age of the runner goes up, you're not necessarily guaranteed that the miles per hour are going to go down, right? You can kind of see this person way out here, they're in their 50s, but they're still running an average miles per hour of a little less than 8 minutes per mile, right? Meanwhile, this person down here, as they are getting older, they're about 60 years old, and they're only averaging about 4 miles per hour, right? So it's not as linear as the age graph, it's not as strong of a correlation as the age graph. So we're going to say that it is a weak correlation, which tells us that age does not necessarily mean that they are going to be running slower.